Welcome back, everyone, to the deep dive. This time, we're going to be doing a deep dive into something called black box science. It's kind of like, those big discoveries and innovations that are kept super secret from the public.
Yeah, and what's really interesting is we're not talking about just small-scale experiments here.
Right.
These the kind of breakthroughs that could totally change everything, like how we live, how we see ourselves, I mean, the whole nine yards.
Okay, so before we get too far, let's just break it down. What exactly are we talking about when we say black box science?
Or imagine like a scientific discovery so huge, so powerful, it's basically kept under wraps.
Okay.
And there are lots of reasons for this. Maybe it's too dangerous to let everyone know about it.
Like weaponizing it or something?
Yeah, like weapons, or maybe it could cause some kind of economic collapse.
Wow.
It could even be, and this is kind of wild, that the knowledge itself is too dangerous.
Like, we can't handle it as a society.
Right. But the point is, most people have no clue these things even exist.
It's like a secret club of knowledge, and only a few people get to be members.
Yeah, and that brings up a big question with black box science. Who gets to decide what we know and what we don't?
That's a good point.
And it's not just a theoretical thing. To really grasp the implications of this, we gotta look back in time.
Okay, so where do we start?
The Manhattan Project.
Oh, yeah, the race to build the atomic bomb.
Right, it was all top secret.
And I think it's crazy that even many of the scientists working on the project didn't even know what they were actually making.
Exactly. It was a perfect example of black box science. And the impact was huge. I mean, the world had no idea this bomb was being created until it was, well, dropped.
It's like that moment changed the entire game of warfare. Forever.
You can say that again? And the thing is, the secrecy didn't end with the war. Even today, that knowledge, how to build nuclear weapons, is very, very tightly controlled.
It makes sense, but it's still kind of scary.
It is a tough balance, trying to control this incredibly dangerous knowledge, but also recognizing it could potentially be used for good.
Right? It's like this constant push and pull between wanting progress, but also wanting to prevent something terrible from happening.
And that's exactly the dilemma at the heart of black box science. Who should hold this knowledge, and how do we make sure it isn't misused by those in power? We need to be thinking about this, especially today, with all the new forms of black box science popping up.
Like artificial intelligence.
There you go, AI. That's like the poster child for modern black box science. We have these AI systems that are doing incredible things, but how they actually work, a lot of that is still a complete mystery.
So how does that work? We create these systems, but we don't even fully understand them.
Yeah, it's called the black box concept in AI. We see what information goes in, and we see what comes out, but the process in between,
Right.
how it gets from A to B, that's often hidden even from the people who design the system.
That's pretty unnerving, especially when you think about how AI is being used in things like law enforcement or healthcare, even the military. We're trusting these systems to make important decisions, but we don't always know how they're getting there.
That's the central dilemma, right? We want progress, we're pushing the boundaries of what's possible, but what happens when those boundaries lead us to knowledge that is potentially very dangerous or brings up a whole host of ethical questions?
So it's like this constant battle between wanting to discover new things and wanting to control them before things get out of hand.
Absolutely. And it goes beyond AI. Think about gene editing with things like CRISPR.
Okay, yeah.
It could change how we treat diseases, but it also could have unintended consequences. Some of the research in that area is kept quiet on purpose, partially to prevent misuse, but also to avoid public backlash.
So you're saying we control the information to prevent harm, but in doing so, we might be holding back progress.
That's the trade-off. And that leads us to another crucial part of this whole black box science thing: power.
Yeah, because it's not just about the science itself. It's about who has access to it and what they choose to do with that knowledge.
Exactly. It's a huge question. Who gets to decide which discoveries are just too risky to reveal? Governments, corporations, a handful of scientists. These are massive ethical questions.
I mean, history kind of shows us that giving too much power to just a few people, well, that doesn't usually end well.
Right.
And when we're talking about black box science, the stakes are higher than ever.
And consider this. Private tech companies are developing some of the most advanced stuff out there, often with very little oversight.
Okay.
They're driven by profit, but if what they're doing could reshape society, who's holding them accountable?
And then there's government secrecy, hiding behind national security.
Right.
But how can we be sure that secrecy isn't being used to silence people or to exploit others?
It's definitely a complicated situation, no easy answers, but we've talked about the history of black box science, the challenges with things like AI, and the whole issue of power and control.
Right.
But where do we go from here? What about the future?
That's the big question. And I feel like we've only just started to scratch the surface here.
We have, and that's what we'll be looking at in the next part of our deep dive. Things are about to get even more interesting.
All right, so we're back, ready to go even deeper into black box science. I mean, we've covered some of the basics, talked about that history and some examples that are happening right now, but what about the future? What does black box science look like in the years to come?
That's the big question, right? This isn't just some interesting history lesson. This is something that's going to keep shaping our world, especially as we push further into unknown territory with things like quantum computing or synthetic biology, even space exploration.
Oh yeah, those are some pretty mind-blowing areas of research.
Right.
And they all have huge GE potential for amazing discoveries. But also, I mean, the risks are huge too.
Yeah.
And then there are all the ethical questions. How do we even begin to approach this kind of stuff?
It's a constant balancing act. We have to weigh the possibility of things going wrong, like misuse or unintended consequences, against the drive for progress. And believe me, there are strong arguments on both sides.
Okay, so let's start with transparency. Like, what would be the good things about being more open about scientific knowledge?
Well, one of the big ones is that transparency builds trust. When the public knows what's going on, they know the risks and the benefits, they're more likely to support the responsible development of these technologies.
Okay, yeah, it's like if you know what to expect, you're not going to freak out as much.
Exactly. Openness also encourages more collaboration.
Okay.
When scientists can share what they're working on, what they're finding out, well, it can lead to faster discoveries, more effective solutions to the big problems we face.
Like a global team effort.
Right. Think of it like a worldwide brainstorming session.
Okay, that makes sense. But we got to be realistic here. There are some real concerns about just letting everyone have access to any kind of scientific knowledge. I mean, it doesn't take much imagination to see how things could go really wrong.
You're not wrong about that. And the argument for secrecy usually comes down to preventing harm. Some discoveries are just too dangerous to let fall into the wrong hands.
Like what kinds of things are we talking about?
We're talking about the potential to create really powerful weapons or disrupt entire economies or even destabilize societies.
Okay, so you're saying the stakes are incredibly high.
Incredibly high.
So it's like a catch-22, right?
Yeah.
On one hand, yeah, you want to keep things secret so they don't get misused and cause chaos. But on the other hand, if you lock away knowledge, even potentially good knowledge, you're kind of holding back progress.
Exactly.
Ugh, how do we even find a middle ground here?
That's where the concept of responsible innovation comes into play. It's not just about making new discoveries. It's not just about making new discoveries. It's about developing and using those discoveries in a way that minimizes harm and maximizes the benefits for everyone.
Okay, I like the sound of that.
Yeah.
But who gets to decide what responsible even means? And how do we make sure those decisions are fair? Like, that seems like a huge problem.
Oh, it is a huge challenge. As of right now, there isn't one global authority, like a set of rules that everyone agrees on when it comes to black box science.
So how are decisions made?
Usually it's individual governments, companies, or research institutions. They decide what to share and what to keep secret.
But they probably all have their own agendas.
Right. And that means there's a lot of inconsistency, a lack of accountability.
So what can we do about that?
We need to start talking about this, and we need to do it on a global scale. We need to develop some ethical guidelines, international agreements, some kind of oversight that everyone can agree on.
But what would that even look like? Like a council of scientists deciding what's safe to share?
It's not so much about creating one central authority. It's more about fostering a culture of responsible innovation. Think about things like making research findings more open and accessible, establishing some clear ethical guidelines for doing research in the first place, and finding ways for the public to be involved and have some oversight.
That sounds really complicated,
Mm-hmm.
especially given how global science is these days.
Mm-hmm.
And the fact that technology just keeps advancing faster and faster, it feels a little overwhelming, to be honest.
It's a big challenge, absolutely, but it's a necessary one. The decisions we make about black box science now, they're going to have a huge impact on the future of humanity. We can't just sit back and watch these decisions being made in secret. We all have a role to play.
Okay, so what can regular people do? How can we be part of this conversation?
The first thing is to stay informed. Learn about new scientific discoveries, especially the ones that have the potential to impact society.
Right.
Don't just accept things blindly. Think critically about the ethical side of these new technologies. Ask questions, demand transparency, and support the groups that are out there working to make sure innovation happens responsibly.
So it's about realizing that we all have some responsibility here. We're not just watching from the sidelines. We're all part of shaping the future of science and technology, whether we realize it or not.
That's exactly right. And the decisions about black box science ultimately belong to all of us. The more informed and engaged we are, the better equipped we'll be to face these challenges, and hopefully create a future where scientific progress benefits everyone.
That's a powerful thought. And it feels especially important now with how quickly technology is changing. Like we're all in this together, whether we like it or not.
That's a great way to put it. And as we move into the final part of this deep dive, keep in mind that this isn't just a theoretical discussion. These are real issues with real consequences.
So we've been talking about black box science in this kind of, I don't know, big picture way. But we got to remember, this isn't just some theory, right? This is happening right now, like in actual labs and research centers and government meetings all over the world.
It's happening everywhere. And those decisions, what to make public and what to keep secret, they have real-world consequences.
Yeah, right.
I mean, look at the Manhattan Project. That's a prime example.
Right, like the Manhattan Project is almost like a cautionary tale.
Yeah.
It shows how powerful this stuff can be and how the decisions made, they had an impact for a really long time.
Mm-hmm.
It also shows how we're always wrestling with this idea of wanting to advance science, but also needing to make sure we can control it. And that feels just as relevant today as it did back then.
Absolutely. I mean, we're living in a time of incredible scientific progress. Things are moving so fast, but with each breakthrough comes a whole new set of problems, ethical questions, questions about who controls that knowledge and how it's used.
Yeah, like with artificial intelligence, that's a big one. AI could change everything. Healthcare, transportation, education, how we entertain ourselves. I mean, the list goes on and on. But there's some real challenges there too, especially when it comes to transparency and accountability.
You hit the nail on the head. The more complex AI systems become, the harder it is to understand how they work, how they reach their decisions. And that lack of transparency, it's a problem because it makes people worry about bias and discrimination.
Right.
And the possibility that these systems could start acting in ways we don't understand or can't predict.
It is a little scary to think about.
Yeah.
We're putting so much trust in these things without fully understanding how they tick.
And it's not just AI, remember. Gene editing with CRISPR.
Yeah.
It has the potential to be amazing for treating diseases, but then you start thinking about, designer babies and what it even means to be human.
Yeah, it's a lot.
It is a lot to think about. It can feel overwhelming with how complicated this all is.
Definitely.
But that's why it's so important to have these conversations. We need to think critically about the effects of black box science, because what we do today will determine what happens tomorrow.
So as we're wrapping up this deep dive, let's go back to that main question. Should we keep some discovery secret? Or does that actually hold back progress? It's such a hard question.
Yeah, there isn't a simple answer. But I think what's important is to realize that it's not a black and white choice. It's not either total openness or complete secrecy. We have to find a middle ground. We have to recognize the potential benefits and the potential dangers.
So finding a way to encourage innovation, but doing it responsibly.
Exactly. And we need everyone to be part of that discussion, not just scientists, not just politicians. Everyone needs to be involved.
So as you go about your day, think about black box science. Think about how it might affect you. Ask questions, stay informed, be part of the conversation, because the future of science, and maybe even the future of humanity, depends on it.
Well said. Thanks for joining us for this deep dive into the world of black box science.
And until next time, keep exploring, keep questioning, and keep the conversation going.